All right. Here we go. So these properties we're going to go over, right, are a little bit more extensive than some of the properties we saw yesterday. You know, some of the basic properties we saw, and what I mean by those basic properties, right? Let's see if I got them somewhere. There you go. Remember, yesterday we already learned some logarithm properties right here. All right, we know that log base a of 1. Okay, so really, anytime you take the logarithm of 1, you're going to get 0, right? Because, again, the question would be a to what power gives you 1? The only power that would give us 1 is when you do to the 0th power, right? Unless it's log base 1, I guess, and then you have a bunch of answers. But anyway, on number 2, excuse me, log base a of a is 1. So when you evaluate log base a of that a again, 1. And then for 3, log base a of a to the x gives you just x. And they're going to expand on some of these properties here now, okay, with different kind of ideas. Understand also that these are true okay, for natural logs, right? So that's when you see like ln, you know, kind of thing. And for common logs, okay, that's just log, right, with no base, and all other logs. Again, I think sometimes students get a little confused, I think, when they see the when they see natural log or just common log, you know, log by itself there, because they don't see the base and they're like, whoa, is this a weird or different thing? No, a logarithm is a logarithm, okay? And so we'll use these properties for all of them. Okay, so first property we're going to look at, log base a of u times v. Okay. Log base a of u times v is equal to log base a of u plus log base a of v. This might seem like a little bit of a weird property, right? Taking multiplication inside your logarithm and then breaking up this multiplication, this product, into two separate logarithms with addition now separating them. Okay? This might seem a little bit funky, but keep in mind here, what are we working with, right? Logarithms and exponents, we know, are related to each other. They're inverses of each other. Don't exponents have a similar property to this? When you multiply two numbers that have the same base, you add their exponents? Well, here we kind of see some addition with same bases, and that means you're going to end up multiplying those u's and v's there. So there's somewhat of a relationship in there. Okay? So let's see an application of this. All right, so for example, if we see log base 4 of 16x. This is a little bit different than the ones we did yesterday, right? If we just had 16, if we just had log base 4 of 16, what would our answer be then? 2, right? Because 4 squared gives us 16. But now we have that x in there, that kind of throws things off, right? It's harder now to think about, okay, 4 to what power gives me 16x? It's like, kind of weird. But we can use our properties here. Since it's 16 times x, we can use that property and say, okay, well, this is the same thing as saying log base 4 of 16 plus log base 4 of x. Okay? And again, now that it's split up, we can evaluate. Log base 4 of 16, we already said was 2. So this is equal to 2 plus log base 4 of x. Okay. And so there's our answer. That's as simple as we can get, right? Because log base 4 of x, we really can't evaluate. We don't have like a, we don't know enough about x to be able to simplify that any further. Okay? So what we did right here is essentially we simplified. And so that might be like the direction you see for a problem like this. Like, how do we know this is what we're supposed to do here? Well, we're trying to simplify. Okay? Sometimes this is also called like expanding, right? We took something that was in a single logarithm and we expanded it to multiple logarithms, and then we were able to simplify some of those parts. Okay? You might also see, a variety of different ways to expand. I mean, for example, someone can maybe look at the 16 and say, oh, but that 16, that's also a product. we could say that that is equal to log base 4 of 4 times 4. Right? So maybe you didn't want to simplify from here. Maybe you saw that 16, you're like, let's break that 16 up into 4 times 4, which then would give us, I'm going to kind of like do something like this. Another product, so we could say log base 4 of 4 plus log base 4 of 4 plus log base 4 of x. And again, log base 4 of 4 we know is what? 1. So that'll be another 1. And then log base 4 of x. And we get the same thing, right? 1 plus 1 is 2, and there's our 2 plus log base 4 of x2. So there's different ways you can go about doing this, right? You might not all follow the same kind of path. Different ideas there. Okay? Questions on that first property? Okay. Let's try another property then here. All right, well, it makes sense here then if we have log base a of u times v. What if we have log base a of u over v? U divided by v. Right? Multiplication in a single logarithm became addition between two. Right? We broke it up. Division then should become what? Yeah, subtraction. Exactly right. So log base a of u minus log base a of v. Okay? Log base a of u minus log base a of v. All right. And so then, just as a quick example of that, let's take a look, for example, at the natural log of x over 2. What can we change this natural log of x divided by 2? What can we change that to be? So, yeah, go ahead, Megan.
The natural log of x minus the natural log of 2.
Exactly right. Okay, very good. Now, maybe someone looks at this and says, wait a minute, Mr. Whitmire, I don't see that as division. What if I say that this is the natural log of 1/2 times x? Is that the same thing? Is x over 2 the same thing as 1/2 times x? It is, right? So then, but now we have multiplication, so this would be equal to the natural log of 1/2 plus the natural log of x. Huh. Well, that's kind of interesting, right? Both of these things have natural logs of x's, natural log of x's, but this one has a minus natural log of 2, this one has natural log of 1/2, positive natural log of 1/2, but they are equivalent. They are equivalent to each other. Kind of interesting, right? But again, two different ways to do that there, so you could kind of avoid the division if you want to. But all right, let's try another property. One more major property here. Log base a of u to the n power. Log base a of u to the n power. All right, and you guys have seen these properties before, right? These are not new to you. You saw them in Algebra 2? Some of you not? Okay, well, all right. So what's the property going to be? What does this simplify to be? N. Is that it? N times log base a of u. Yeah. So in other words, that exponent for the u, that n, that can be brought out front. Okay. What's the idea here? What's the principle? Well, if you have log base a of u to the n, we can basically use our first property here. This is really just an extension of our first property to find that third property here. Excuse me. Log base a of u to the n, that's the same thing as saying log base a of, well, u to the n means u times u times u times u times u times dot dot dot. You get the idea. How many of these u's are we going to have? If it's u to the n, there's going to be n of these u's. Okay? But we know from our first property that since this is all one big product, right, all of these times u's times u's times u's, that can be then log base a of u plus log base a of u plus log base a of u plus dot dot dot. You get the idea, log base a of u there. How many of these separate log base a of u's will we have? N, right? We'll have n of them. What do we call repeated addition? when you add the same thing over and over again, what is that operation? Multiplication. N times log base A of u. Right there. Okay. N times log base A of u. So we just really, that's just an extension of property 1. Okay. We can also use, question, Cooper, or you're just stretching. So we can also use this to go back to number 2 here and see how these two things are the same. 1/2 is the same thing as what power of 2? 2 to the what, sorry? -1. What can we do with this -1 exponent that's inside the natural logarithm here? Using property 3, where can that -1 go? In front here, right? Negative natural log of 2 plus the natural log of x. Isn't that now the same thing as that right there? Natural log x minus natural log 2, negative natural log 2 plus natural log x, the same thing. Okay? So you end up with the same thing there. Okay. That's all using properties. Okay. So let's try here. So just another example real quick of this one. How about log base 3 of 9 to the 5th? Log base 3 of 9 to the 5th. Okay? So how might we be able to simplify something like this? Log base 3 of 9 to the 5th. What can we maybe do here? Okay, Julia?
You could do that, you could find the square root of the 9 and then put it as 3 and then times it by the power of 5.
Okay, all right, you're doing, yes, that'll work. I want to come back to that step though. How can we use that property 3 here to rewrite this? Make it 5 times log base 3 of 9, right? We'll get to what you're saying, Julie, because yeah, you're onto something there too. Okay? What's log base 3 of 9? 2, right? 3 to what power gives us 9? 2. So it's going to be 5 times 2 here. So just 10 is our final answer. Okay. Right. What Julia was saying here to do is to rewrite 9 as a power of 3. 9 is 3 squared. So instead of 9 to the 5th, we can rewrite that as 3 to the 2 to the 5th, right? Isn't that what you were saying to do? Yeah. Okay? And then since we have a power to a power, log base 3 of 3 to the 10th, right? 2 times 5 is 10. Well, this is one of our basic properties we learned yesterday, right? Log base 3 of 3 to the 10th. In other words, 3 to what power gives us 3 to the 10th? The 10 power there, power of 10. So you get it that way too. Okay. So there's lots of different, avenues to take in some of these cases. All right, different ideas, and you can use, a combination of these properties to kind of still get the same answer but take a different path. Okay. Any questions on those 3 properties? No? So I want to be very careful here. There is no rule for log base A of u plus v or log base A of u minus v. You cannot break up a sum inside a logarithm, okay, using any of these properties, right? You cannot break up a difference in a logarithm using these properties, okay? Please do not try to do this, okay? So when you have u plus v inside the logarithm, you're done. When you have u minus v inside the logarithm, you're done, okay? If you have a difference outside, so here again, we have a difference between 2 different logarithms, this difference, log minus log, then you can put that together as a single logarithm, u over v, right? Here where it's log plus log, then you can put them together as a single logarithm, u times v. But if it's a single log of a sum inside, it can't be broken up. Or a difference inside, it cannot be broken up. Okay, so please don't try to do that. There's no property for it. Okay? So, let's continue here. All right. So, how are we going to use this? So, uses. Okay, one use is evaluating logarithms, right? We already kind of saw an example of this here earlier. Let's do another one here, and then I'll have you guys try one. All right, so let's see here. Let's, again, simplify log base 5 of the square root of 50. log base 5 of the square root of 50. So I don't immediately see a product here that I could break up. I also don't immediately see a division here, or a quotient that I could break up. And I kind of don't really see u to the n, like where I could bring the n out front. But how can we rewrite a square root? A square root is the same thing as what exponent? It's equal to 1/2 power, right? So square root of 50 is the same thing as 50 to the 1/2 power. Now that I have that 1/2 in my exponent, what can we do with that 1/2? Using our properties. We can bring it out front, right? 1/2 log base 5 of 50. Okay. Is that the best we can do? Right? Just by me asking that question, you're like, no, Mr. Ware, we know there's more, but I'm not sure what to do. Right? Maybe not. Maybe you do know what to do. Any ideas here? What can we do here further to simplify this sum? Our logarithm is log base 5, okay? So we need to look for things that are powers of 5. Is 50 a power of 5? No, it's not, but can we break it up into some powers of 5? So like what can we break 50 up into? 25 and 2. Okay, very good. So let's do that here. So log base 5 of 50 is the same thing as, 1/2 log base 5 of 50 is the same thing as 1/2 log base 5 of 2 times 25. Okay. Aha, we have a product inside our logarithm. So what can we do then? Break that up into what? Addition. Okay. Notice both of the logarithms get a 1/2. You can think of this 1/2 out front. It distributes to both of the terms in the sum there. Okay, both terms in the sum. Okay, so the 1/2 is in front of both logarithms there. All right. Can we simplify log base 5 of 2? No. Yeah, unfortunately, that's going to have to stay 1/2 log base 5 of 2. Okay. Can we simplify log base 5 of 25? Yes. What is that? It's 2. And so they end up with 1/2 log base 5 of 2 plus 1. And that's our final answer there. Okay, that's the best we can do. Best we can do. Okay? Because there's no easy way for us to take 5 and rewrite it as a power of 2. So we have to kind of leave it there. Right? 5 to no nice power gives us 2. All right, questions on any of that? Ready to try one on your own? I will take your silence as a yes. All right, so try this one here. Simplify. Okay. Natural log of 4e to the 5th. Natural log of 4e to the 5th. Simplify as much as you can. Much as you can. So yeah, good. So do that. Do that for your first step. Okay. Take it a step at a time. All right. So it's not 4 to the e to the 5th, it's 4 times e to the 5th. 4 times. Okay? And then you don't want to bring that 5 out because the 4 and the e are not both being raised to 5, only the e is being raised to the 5th power. So break up the product, 4 e to the 5th first, break up the product there, and then you bring the 5 out from it. E to the 5th isolated. Lost? I found you. You're right. Thank you. Alright, what's
Isn't it 5 lines, not 6?
Yes. It's not there if you wanted to.
Also, it's around like that, 4 is a bigger
That was right. That's okay. What is that? So, remember so what power is so that's log base.
Oh, okay.
Yeah.
Because 4 is not power, 4 is just 4. It's not
Yeah.
Ben's mad at you.
Where is your chinchilla?
I don't know how to say it.
What if they try to talk to
You spank them.
Over anybody.
The only thing you say to them is you are blessed.
Oh, yes, you never read
It can
It should be
be.
part of the
No, opportunity could write more than where you want to. That I would just say. But bring that one in.
No, that was just like hard.
Yeah, the daily. Alright. Yes.
I think I got it. That wasn't a daily.
So almost that P is 1 because that's what is log base E. Log base E. One. So it's just 5 times 1. 5. Okay. There's our answer. Okay. Either one of those two, I would say it's debatable about whether 2 natural log 2 or natural log 4, whether which one is simpler than the other kind of deal, you know. So I won't argue if you put either one of those there. All right. Questions on any of this though? Okay, so this is like this is us trying to evaluate as best we can, you know, this solution, right? Okay, but of course it's the best we can do because natural log 4 isn't a nice number, right? But we get something at least. All right, let's continue on though. So that's one way is just evaluating a logarithm. Another use of these properties, another use that you'll be responsible for, okay, is what I call like expanding. Okay. So taking a single logarithm and rewriting it into a product or sum of logarithms. Okay, so taking a single log and rewriting as a sum/difference of logs. So, example. Log of 5x to the third y. So we want to take this single log and rewrite it as a sum or difference of logs. Okay. Now, we have how many things being multiplied together here? 3, 5, x cubed, and y. And so, since it's all a product and a product, right, it's times and times, we can change those from multiplication to what? Addition, right? And so we'll just say, well, it'll be log of 5 plus log of x to the third plus log of y. Okay. Is there anything else we can maybe still do here using our properties? Okay, what would that be? Yeah.
Taking the n, which is the 3, and
Yeah.
putting it in front of the log
So,
x.
yep, the exponent here for 3, for x, sorry, we can bring that 3 in front. Now again, I'm going to say that's up to you whether you want to do that or not. I don't think it's necessary, like you could stop right here if you want to, but just for the sake of showing it. Voila, there it is, okay, mind blown, right? Okay. We put the 3 in front. Okay. Questions on any of that? Now, can we simplify log of 5? Remember, log by itself is log base what? 10. And can we raise 10 to a nice power and get 5? No. And so we're not going to simplify this. But if this was like log base 5 of 5, you should simplify that to just 1. Okay, so watch your base. Check to make sure that you can't simplify those numbers when you get that. All right, let's try one more together here, and then I'll have you guys try one on your own. Natural log of 20 times the square root of x over y. Okay. So ideas here about a good place to start? Which property might be a good place to, what might be the property to start with, I should say? Riley?
Change the square root
To a,
of 1/2 x squared.
okay, we can do that, yep. That's not what I was thinking, but I think that's a legit way to go here. So you want to see something like this? Okay, the quantity x over y was we're taking the square root of that, so the quantity x over y should also be to the 1/2 power. Okay. Now from here, what might be a good next step then? What might be another good property to use at this point or something? Okay, so Hayden says separate the 20 and the times the x over y to the 1/2. So that will be multiplication in here, which will change to then what? Addition. So natural log 20 plus natural log x over y, that quantity to the 1/2 there. Okay, is that all we? Oh, Hayden, question, comment?
I want to answer.
Oh, okay, all right, go ahead. What do you want to do next?
Wait, can I do the whole thing?
Sure.
Okay. ln 20 plus 1/2 in parentheses ln x minus ln y.
Okay, yes, we did two things at once there, okay? So, first of all, the quantity x over y was being raised to the 1/2, so we brought that 1/2 in front, okay? But then Hayden also saw, hey, wait a minute, we've got x over y here, that's division, which we can then change to subtraction. Notice, Hayden correctly identified we should put that in parentheses, because that 1/2 has to distribute both terms there. Okay? It's up to you if you want to then continue and actually distribute the 1/2, that's your choice. You can leave it like the way it is too, okay? I mean, that's fine as well. 20, technically you could break it down into like 5 times 4 if you wanted to, but again, that's debatable whether it's any simpler. Natural log is log base what? E. Natural log is log base E, and none of these are powers of E, so rewriting it, to try and get a power of E, that's just not going to be helpful. So we'll just stop right here and say that's the answer. Okay. Any other questions or comments on that one? Oh yes, Ramike.
When you the first step to the problem,
The square root of x over y?
Yeah.
Yes.
Subtract those two.
Yes, so yes, alternative here, and this is where I was actually, that's where I went in the past, it would be something like this. Something like that, and then you can take the square root, make that to the 1/2, bring the 1/2 out front, and then do the division and stuff like that. So yep, that would work. Dot, dot, dot. All right, here's one for you to try. Natural log of the quantity square root of 3x plus 5 over 7. Okay, so go ahead, expand that out as much as you can. Okay, expand that out as much as you can. And make sure you don't expand out more than you can, too. It's not always about knowing what to do. It's also knowing about when to stop, too. Oh, because well,
Yeah, my legs are nice. Yeah, I might just change it to an H.
well, if that's the messiest your life ever gets, Hayden, you'll be doing all right.
Can you stop my items? I'll give you half of a pretzel. Yeah. You're welcome. Bigger half.
Okay, questions on that? Too easy? Get on with it? All right. Fair enough. Well, if we can expand, then we can also condense. Okay, this is a little bit more clear, I think, because the rules are typically rewrite as a single logarithm. And this equates to working backwards in our properties. What we once separated, we're now going to put back together. Okay? Or where we once separated, we'll now join back together. So I'll do an example or two. So now we have two logarithms separated by addition. How can we go about putting them back together? What can we do here? First step. Megan, what do you say?
Put the two, like, make it log 4 of x squared.
Okay, right. So the 2, that is a coefficient right now. We can move it up back to the exponent position of the x. So it'll be log base 4 of x squared plus log base 4 of 5. Okay. I'm glad Megan didn't say, and I don't know if you mentioned it, I'm assuming she did, right? But she did not say, oh, let's put these two logarithms together, right? We're adding them together, right? We make it a multiplication. Well, not quite. There's 2 in front here. We need to bring the 2 up first. Then now we can put them together. And so what's our final answer going to be here, Megan, if you don't mind saying?
Log 4 of 5x squared.
Of the quantity, yeah, of the product there, 5x squared. That is our final answer. Okay, log base 4, 5x squared. Okay. All right, one more here, and then I'll show you change of base. 1/2 natural log 5 minus 3 natural log x plus 3 plus natural log x. So, just like in the previous one, all of our coefficients, we want to rewrite those as what? Bring them up into the exponents, right? Make them powers. So 1/2 natural log of 5, we're going to make that natural log of 5 to the 1/2 power. Minus, and then that 3 natural log of quantity x plus 3, we'll make that natural log of the quantity x plus 3 to the third, like that. Okay. Now, did anyone bring -3 up into the exponent? Because you could do that too. If you brought a -3 up, then it become plus natural log x plus 3 to the -3rd. Okay, so you can do it that way. But it looks like no one else did, so that's fine. And then, okay, natural log of x does not have a coefficient, so we'll just leave it natural log of x. Okay, it's really sloppy here. Okay. All right, now, how can we go about combining these things together? Well, I see subtraction. So subtraction between these two logarithms means we should change it to what? Division. So 5 is going to be 5 to the 1/2 will be divided by x plus 3 to the third. So in other words, it'll be the square root of 5 over x plus 3 to the third. But then we still have plus the natural log of x. And so to combine these two together, how are we going to combine those together? Multiplication, yeah. Okay. So we multiply an x there. But really, where can that x go, though? Where can it actually end up? Up in the numerator, right? Because this is really x over 1. And so the x and the root 5 will multiply. The 1 and the x plus 3 cubed there will multiply. And so it's really natural log of x root 5 all over x plus 3 to the third. Okay. Jackson, do you have a question, or is that what you're going to point out? Gotcha. Okay. Easy. Easy, easy, easy. Okay. Last thing. And this is called change of base. Okay? Because our calculators, right? Our calculators are able to do what logarithms? If you look on your calculator there, next to the 7, you see log. So we can do log base 10. If you look next to the 4, you'll see ln. So we can do natural log. If we want to do something like log base 2 of 32, we can do that, right? What's that going to be? 5, right? 2 to the 5th is 32. So log base 2 of 32 is 5. Right, but if we want to do this in our calculators, there is no log base 2 button. However, log base 2 of 32, we can change the base, right? The problem with evaluating this in our calculator is our calculator doesn't have log base 2. Our calculator is log base 10. How do we change something that's in terms of 2 to be in terms of 10? Log base 10 of 32 over log base 10 of 2. So if we want to convert something that's log base 2 into something like log base 10, then you just take the big number, the 32, do log base 10 of 32, divided by log base 10 of the base 2, like that. And these are mathematically equivalent to one another. Okay? Which means that this is also equal to the natural log of 32 over the natural log of 2. Right? These are both log base e, or in general, log base a of 32 over log base a of 2. Okay, but of course, we chose to use log base 10 and natural log because that's what's in our calculators. And if you type that into your calculator, okay, so you type in log 32, close parentheses, divided by log 2, you get 5. If you do natural log 32, close parentheses, divided by natural log of 2, you get 5. Okay. So same answer, regardless, which it should be, right, if it's change of base there. Which is helpful because what if we get a problem like the log base 2 of 30? And we want to evaluate that. Right? Can we do this mentally? No, but you should have an idea about roughly what it should equal. Log base 2 of 30 should be roughly between what two numbers? What two whole numbers? Between 5 and 4, right? Because we just saw log base 2 of 32 was 5, right? 2 to the 4th, well, that's 16. So this is going to be somewhere, this is somewhere between 16 and 32. So it should be equal to something between 4 and 5, right? Okay, by the intermediate value theorem. Okay, something you learn more about in calculus and stuff. In fact, we'd expect it to be closer to what number, the 4 or the 5? Probably closer to the 5, right? So let's just try it here. So again, change of base. You can use either log or natural log. I'll use natural log in this case. Natural log 30 divided by natural log 2, 4.9. 0.6890596. Okay, so this is about 4.907. I'll say there. Okay, and you can check that by doing, okay, let's check that. 2 to the, and I'm just going to use the answer command, which allows me to use that. So this is saying this exponent of 2 should give me 30. And there it is. Okay, if you don't believe me, you can type it out. 2 to the 4.906890596. And they're rounding because the calculator had to round off there, right? Which is about 30. That's the question. That's the answer. Right? Questions on any of that? Change of base. All right, so that concludes all the material that you could potentially see on Thursday's quiz, okay? So let me go ahead and post to Google Classroom our homework, and you guys can go ahead and get started on your assignment. Yes?
I also found the log base thinking.
Yeah, there's also that command too.
Because my friend taught it, she